Okay, today we'll look at functions and loops in Bash. Firstly, we'll look at functions. A function is a block of code that does a specific task. You can call it whenever you want without repeating the instructions. For this, I'll open the file. There are two ways to declare a function in Bash. Let's look at the first type. I'll write function and movie name. Movie name is the name of a function through which this function can be called. If I write echo $1, which prints the first argument that was passed to this function, I can call this function by simply writing the function name over here. We can pass the arguments to this function by giving space. If I again call this function by writing movie name and kgf, the function will be called two times, and each time the first parameter that was passed to this function will be printed, which means salar is the first parameter and kgf is also first parameter. If I add some more parameters to this first function call, and if I write $2 and $3 in the function definition, we can collect the parameters passed while calling the function as $1, $2, $3 and so on. If I save and execute the file, there are no second and third parameters in the second function call. There is only one parameter, and that's why only kgf was printed. Okay, now look at the second way of declaring the function. I'll open the same file. If I remove the function keyword and add opening and closing parentheses after the function name, now this will become a function. Now this function will also behave in the same way as the previous function behaved. Now if I write -e in the echo statement, \n here prints the rest in the next line. Without -e in the echo statement, the \n will be printed as it is. If I save and execute the file, the output is similar to the previous one. As we have added \n, the rest was printed in the next line. Now let's add some more fun to this video. Now let's learn recursion in Bash. I have opened two side-by-side terminals. We can understand this topic in the better way. I'll reopen the same file. Let me clean up everything. Recursion is when a function calls itself to solve the problem. Each time it calls itself, it breaks the problem down into smaller parts until it reaches a simpler case. It can solve it directly. Now let's try to print the numbers using recursion. I'll write a function numbers and I'll pass 5 as a parameters to this numbers function. Now let's write the base case. Each recursive function must have the base case. As in recursion, function is calling itself for many times. We must tell where we have to stop. Here I have written when the number becomes 1, print 1 and stop the function callings. Now this is the base case. When calling numbers function, inside the numbers function, as $1 minus 1 is arithmetic operation, we already know that we have to use double parenthesis. We also know that whenever we want to store this type of arithmetic operations inside a variable, or when we ran a command and wanted to store that result, we have to use dollar before it. Now if I write echo $1 above the function call and save the file and execute on the left side. Okay, can you guess what's wrong with the script under 5 seconds? This is because though I have written a base case, this base case here doesn't mean when the number becomes 1 stop. Here if the number was 1, it was printing 1, and again calling the numbers function, it was continued for -1, -2, -3 and so on. But if I write else, we already know how if-else block in Bash work, right? Not only in Bash, in any other programming languages, suppose if block was executed, else will not get executed, and vice versa. Here, if number is not 1, then only the numbers function will be called again. But when the number becomes 1, it was printing 1, and again it is not calling the numbers function. Hope you understood. If I save and execute the file on the left side. Okay, now the output is as expected. For suppose if you want to debug the script, which means wanted to know what was happening at each line, here we have to write set -x. For suppose if you want to stop the script execution when some error occurs in the script, you have to write set -ex. Okay, when I save the file and execute on the left side, I got an output something like this. At first, the control is at numbers of 5. Firstly, the shell is checking whether 5 is 1, and that's why this 5 double equal to 1 on the left side. Here the if block was failed, and that's why the control is at else block. The first line at the else block is echo $1. $1 here means 5, right? and that's why echo 5 was at the left side, and 5 was printed on the terminal. And next, numbers function was called by passing 4 as a parameter. Again 4 equal to 1 was checked, failed, and control is moving to the else block. Echo 4 was the line and 4 was printed on the screen, and again numbers of 3 was called. This gets repeated for all the numbers. When numbers of 1 was called, when the control moves to if block, 1 equal to 1 is true, right? And the next line is echo 1. The same line was printed on the screen and 1 was printed on the screen. Okay, now let's write a script to find the factorial of a number in bash. You might have already known what is factorial and how to find it. Even elementary kids know it nowadays. What is factorial? Sorry, I forgot. If you take a number, for suppose 5 into 4 into 3 into 2 into 1 is a factorial of 5. Now I'll write base case for this factorial function. If the value was 1, you have to print 1. If the number is not 1, else I'll write a local variable temp, which means I can use this variable only inside this else block. I have written $1 minus 1. This is because when I receive 5, I have to pass 4 to the factorial function, right? As this is an arithmetic operation, I have to use double parenthesis, right? As I'm storing this value inside this temp variable, I have to use dollar before it. Now I'll call this factorial function by passing this temp variable. Now I don't know the factorial of 5. So I'll write 5 into factorial of 4. When the factorial function was called for 4, again the same steps are repeated. Again 4 into factorial of 3 was called, 3 into factorial of 2, 2 into factorial of 1. This is how recursion works. As this is an arithmetic operation, I have to use double parenthesis. As I'm storing this into a variable, I have to use dollar before it. I have written echo result, and when I save and execute the file on left side, you can see what was happening at each line. Okay, instead of dollar result, I just printed res. At first, factorial of 5 was called. 5 equal to 1 was fail, and that's why the control moves to the else block, and inside temp variable 4 was stored, and factorial of 4 was called, and 4 is not equal to 1, and the control moves to the else block, and inside temp 3 was stored, and factorial of 3 was called. And when factorial of 1 was called, as 1 equal to 1, if block gets executed, echo 1 is the line, but 1 was not printed on the screen. Can you guess why 1 was not printed on the screen? This is because the value 1 is not returned to the terminal to be printed. Instead, it is returned to the previous call. In the same way, factorial 2 returns 2 to factorial 3, factorial 3 returns 6 to factorial 4, and finally factorial 5 returns 120 to terminal. And that's why 120 was printed on the screen. I hope you understood. Let's jump to loops in bash. Okay, let's start with simple for loop. Let's write a bash script to print a numbers from 0 to 4. I'll write for I equal to 0, I less than 5, and plus plus I. As this contains arithmetic operations, we have to use double parenthesis. After that, we have to write do and then done. This is a syntax of a basic for loop. If I write echo $I and then save the file and then execute, the numbers were printed on the screen. You can see what was happening at each line while executing the script. You can comment out this feature by using hash before it. When I save the file and execute, I can only see the numbers now. I can even skip I++ over here, and I can write inside the loop as well by putting double parenthesis. When I save this file and execute, we can see the output as expected. I can even use let instead of double parenthesis for arithmetic operations. When I save this file and execute, we'll see the output as expected. There is another way of writing a for loop in bash. For suppose if I want to write 1 to 10 numbers in bash, I'll write for I in 1 to 10 by putting 2 dots over there, and then I'll write echo $I. And the output is as expected. For suppose if you want to print the contents of the file using for loop, okay, there is a movies.txt file in this directory. If I try to print the contents of the file, there are some movie names over here. Now here path is a variable that is holding the location of movie.txt file. Now using cat $path, we can print the contents of the movies.txt file. We already know that we have to use dollar over here. Now loop then places each item from the file into the variable I. This for loop places each line inside I instead of each word. If I write movie name is $I and save and execute, we can see movie names KGF, Salar, Bahubali and so on. As I already said, for loop does not process each word in a line individually. It treats whole line as a single string. So if you want to print the word by word, then while loop is better. Now let's look at the simple syntax of while loop. Here also if I want to print numbers from 0 to 4, I'll write while I less than 5, do echo $I. I can even increment I like this also by putting I equal to I plus 1. As this is arithmetic operation, I have to put double parenthesis. When I save and execute this file on the left side, the output is as expected. Now if you want to print the contents of the file using this while loop, if I print movies.txt file, I have shifted Salar and Bahubali to the first line. Now KGF is the first word, Salar is the second word and Bahubali is the third word in the first line. In second, third, fourth lines, there are no second and third columns. For suppose if I want to print the second column from each line, then in this type of scenarios, while loop can be used. I'll write while IFS, which means internal field separator, which means any delimiter. I can use colon, semicolon, comma, anything. Words in a line are separated using these delimiters. Here x1, x2, x3 over here means first word was stored in x1, second word in x2, third word in x3. If I write echo $x2, I must also specify from which file we have to read by putting less than symbol over there. If I save and execute the file, I see only Salar was printed, as Salar is the second word from first line and there are no second words in remaining lines, and that's why nothing was printed on the screen. Okay, now let's finally look at until loop. I'll now comment the existing script. I'll write double less than symbol. I can write anything over here. For now I'll write loop. If I write loop anywhere, up to then the entire script will be commented. Until loop syntax looks similar to the while loop, but it runs until a condition becomes true. If I want to print first 10 numbers, until I greater than 10, do done echo $I, which means until I was greater than 10, this loop will be executed. Whenever I becomes 11, this loop was terminated. This syntax is similar to the while loop but works opposite to the while loop. If I save and execute the file, and the output is as expected. Okay, that's it for this video. Hope you liked it. In the next video, we'll look at how to automate the bash scripts.